I think something that's very important to do, especially for like foundational maths, especially things like algebra, like solving a quadratic is quite foundational, is not to just introduce it as like a set of steps to solve a random equation, is to actually show what's going on and what those steps are actually doing. And I think there's a really beautiful way to solve a quadratic without using any algebra. It's just kind of by using spatial reasoning and shapes. So first thing we can think about is that we have three different types of terms in a quadratic. We have one with just variables, one with a combination of numbers and variables, and one that's just a number. By the way, for this video, I'm just going to be doing ones with coefficients of 1 for the x squared, but I will show that this method does kind of work for other ones. And the kind of main thing here is this middle term, because this middle term kind of acts as a bridge. We have two different types of numbers. We have a variable, and then we have a normal number. And then this number in the middle is kind of like the bridge between the two, because it has a number and a variable. So basically, the kind of idea here is when you're adding things together, in terms of area, we can think about this being represented by area. So this x squared is a square of side lengths of x, 7x is a rectangle with lengths 7 and x, and 12 can be anything. In this case, it works out well if it's 3 and 4, and I'll show why in a second, but you can write this as 6 times 2, or you can write it as 12 times 11, whatever you want. And when we add all these shapes together, obviously x can be different things, we want the overall shape to be equal to 0. Or the overall area to be equal to 0, sorry. But the problem is we have three different shapes we have to worry about, and if we change x, both of these shapes change, and then we have to kind of like visualize how they all go into each other. It's very difficult to do. So what would be very helpful is if we could somehow combine this into one shape, and then it's easier to see how we can make the area 0, because obviously if we have one big rectangle equal to 0, then one of the sides has to be 0 to give it an area of 0, but I'll get into that later. So how can we combine these to get one shape? Well, the problem is we can't really combine them because they all have different side lengths. I guess we could combine these two because they both have a side length of x, as you can see like that, but then there's no way to add on this 3 and the minus, or this 12 here, so we have to kind of think a bit harder than that. So the reason that 3 and 4 is such a good option is because we can actually break up 7 into 3 and 4, and then we have something really nice going on, that we have this has an x, and then we have a 3x and a 4x, overall it's 7x, but if we break it up to a 3x and a 4x, then we can slot both of them on here, and we still have the x. So let's give that a go. Let's break this up into 3x and 4x. So if we take this shape, so we're going to keep this one the same, and we're going to keep this one the same. Okay, I'm going to bring them down here. But I want to break up the middle one, as I said. I'm going to break that up into 3x. So 3x. So this side is x, and this side is 3. And then we have plus, and we want to break it up into 4x, which would look like this. I'm just going to move this over. And there's a plus here. And then this one is x and 4. And now we notice we can actually slot these on together. It would actually help if we rotated this one around, so we can slide it in with that 4 there. So that's what I'm going to do. I'm going to rotate this around to make it 4x just like that. So now it's 4 and x. And now we should be able to combine all these together, because now that this is 4 and 3, we can slot them together into these. So I'm going to get rid of the pluses, and you can just kind of see what I'm doing. So we have this 4. I'm going to just get rid of it, because I'm going to slide this one on. And now this shape is x plus 3, because we have a side of x here and then a side of 3. Add them together, it's x plus 3. We can bring this shape underneath here, which means that this side here, this big long side, is 4 plus x, because of this x here. So I'm just going to write this side as 4, and then this side is x. So this side is 4 plus x. And then as you can see, we can finish off the shape by bringing in this x square. We can bring that down to here. And now you can see we combine it all into one shape. And we know that the area of this shape still has to be equal to 0. And now I'm going to get rid of some of the numbers. I'm just going to leave the ones on the outside. So this area, this rectangle has an area of x plus 3 multiplied by 4 plus x, and that has to be equal to 0. So you can think of something that has an area of equal to 0. You can think of that as kind of like a line, just like this. Obviously that has no area because it has no width. So we can do that with our rectangle. So I'm going to draw it out again, just quickly. So we have 3 plus x, then 4 plus x. I think this is the same shape. Yeah, it is, as you can see. So what we can think about is, let me change write in the side lengths as well. So this side is 3, or x plus 3, I think I had it as. X plus 3, and this one is 4 plus x equals 0. So one way to make this area equal to 0 is if we reduce the width to 0. So if we reduce this to 0, now the area is 0. So how can we make this side 0? Well, it's some number plus 3, and we want it to be 0. So what number do we have to add to 3 to get 0? Well, that's right, 0. So we'd have to make, or 3 minus 3, sorry. So if we made x minus 3, then that means that the side of this side of the rectangle will be equal to 0, which means it has an area of 0. And then on this side, you can see 4 plus x. How could we make this side equal to 0? So we have 4, and when we add something on, we want it to be 0. So what's the opposite of 4? Well, it's minus 4. So we could say x equals minus 4 as well. And there, they are our two answers. So if you make x minus 4, we have minus 1 multiplied by 0, which is 0 as the area. And if we make it minus 3, we have 0 times 1, which is also 0 as the area. So that's it. And you can see why it was useful to write it as 3 times 4 and write the set, because then we can write the 7x as 3x plus 4x. If we made this like 6 times 2, for example, let's do that. 6 times 2. And we get the same area, because it's still 12. But the problem now is we can't really split up the 7x into a 6 and a 2. Because in order to get a side length, we'd have to have a 6x and we'd have to have a 2x, which gives us 8x in total. There's nothing we can do without adding on extra stuff. So that's why the factors of the last number have to add to give you the middle number. Because in that way, when you break this up into 3 and 4, it's still the same as 7x, and they'll be able to slot in here. So that's kind of like an interesting thing to think about. I might talk about a bit more about how it works and how we can use it for other things. But yeah, that's just an interesting way of thinking about quadratics.